Bismillahirrahmanirrahim. Assalamualaikum and good morning to all of you. Welcome to the first class of BAA4273, the Earthquake and Wind Engineering. Today, for the first topic, I will discuss about the earthquake hazard. Okay, the earthquake is the ground shaking, which is caused by the sudden release of energy. This is the two main keywords. Okay, this the ground shaking and sudden release of energy in the Earth's crust. And then the Earth's plates move with respect to one another. Due to the movement, the stress build up, and due to the frictions, the stress stop, and then it's being released in form of seismic wave, which induce the ground shaking. Okay, as you can see in this figure, this is the original position of two plates. This is let's say this is plate number 1 and this is plate number 2, and then it moves in different directions, and then the stress build up in the connections, and then after certain times the energy stored is too large, and after rupture the land rebounds, and then the movement and the energy release cause the seismic wave being generated. Okay, so this is today's presentations, which is the source of earthquake, magnitude and intensity, and then the earthquakes induced hazard. Okay, there is several major plate movements around the world, which is known as the North American plate, the Pacific plate, South American plates, African plates, Indo-Australian plates, Antarctic plate, and Eurasian plates. And this figure also depicts the highest intensity of seismic around the world, and we are located here, which is in the Pacific Ring of Fire. Okay, we are surrounded by Indonesians and the Philippines at the east. Okay, so this is before you learn more about earthquake engineering, you have to know the terminology of some words. Okay, which is the first one is the focus. Focus is the point under the Earth's surface where the rupture is said to have originated. So under the Earth's surface, the point where the earthquake originated is known as focus, and the focal depth is the distance from the Earth's surface to the point of focus. While the epicenter is the projection of the focus on the ground surface. Okay, so the focal depth differentiate or distinguish the type of earthquake. I mean, the depth of earthquake is differentiated by the law macam mana cakap ya, dia kedalaman earthquake itu menentukan sama ada dia adalah shallow or intermediate or deep earthquake. Okay, for the shallow earthquake, this is very popular in Ranau and Kudasang. Okay, where the depth of focus is around 10 kilometers from the Earth's surface. So the shallow earthquake is very dangerous because this is very close to the Earth's surface. So the fault is the fractured surface in the Earth's crust. Okay, we name it as the fault plane. Okay, this is the fault. And we have two types of fault, which is the deep slip and the strut slip. Okay, where the oblique slip is the combination of deep slip and strut slip movement. So what is deep slip? Deep slip fault is when the one block moves vertically. This is the key point, vertically respect to the other. Okay, we have two types of deep slip fault, which is first is the normal fault, and second one is the reverse fault. For the normal fault, the foot wall moves away from the hanging wall, which is caused by the tension. Okay, you must know on how to sketch Okay, it's important. You must know how to sketch the normal fault and how to sketch the reverse fault. Okay, you must know also the block. Okay, under another block. The block at the bottom is known as the footwall block, and the block at the top is known as the hanging wall block. Okay, when it moves away from one another, we call it as normal fault. Okay, due to the tension. Okay, you can see here in the figure, this is the fault line, and you can see that these two blocks move away. So this is the normal fault. And the reverse fault is when the footwall move towards each other. Okay, where the footwall move toward the hanging wall. And this one is caused by the compression. Okay, this type of fault is very dangerous, and if the epicenter is in the ocean, so it have a very high probability to cause the tsunami. Okay, you can see from the YouTube. Okay, you can search the animation of how the earthquake can generate the tsunami. Okay, you can see that this is the, say this one is original situations. Then when the fault occur, one block will move to the top, and one block will move to the bottom, and the movement of the block will cause the ocean water to rise up, and then will fall again, and then when it comes toward the beach or coastal area, the wave will become higher and then hit the surrounding. Okay, and another type of fault is the strike slip. Okay, the strike slip is when the adjacent block moves horizontally past one another. This is the main keyword, horizontally. Okay, we have two types, which is the left lateral and then the right lateral. Okay, how to differentiate the left lateral and right lateral? Okay, just imagine that you are standing here. Okay, you are standing here, and then you see that the block or the area or the region in the front of you move to the left. So we name it as the left lateral slip. Okay, if you are standing here, okay, let's say this is block A and this one is block B. Okay, you are standing on block A, and then you see to the block B, you will realize that block B move relatively to the left if you are standing on block A. Okay, and here also similar. This is block C and this one is block D. You are standing here on block D. You can see that all the objects move relatively to the right. And if you standing on block C, you look to the block D, you can see that all objects relatively move to your right. So we call it as the right lateral slip. So this type of slip will not induce tsunami if it occur on the ocean. Okay, so this is the seismic waves. Okay, we have a body wave which travel through the interior ground layer, and then you have the surface waves which is travel through the ground surface. So this one is very close to the Earth's surface. Yeah, and this one is very dangerous, where the wave move in elliptical vertical plane. Okay, so, and this is about the magnitude and intensity. Okay, we must know about the modified Mercalli intensity. Okay, we have a total of 12 scales, and we can correlate, okay, between the modified Mercalli and then the Richter scale. And then this is the evaluations. Okay, scale number 1 of modified Mercalli is insignificant earthquake. where it only can be detected by the instrument, and very light, okay, more than 2.0 Richter scale to 2.9. It is a very light earthquake, which is only can be felt by sensitive people. Okay, and we can observe the oscillation of hanging objects like fan and the lamp. Okay, and then the higher the scale, means the greater the earthquake. Then this is the correlation between the magnitude and the energy release. Okay, from this graph, we can see that the number of earthquakes with high intensity is lower compared to the number of earthquakes with a lower intensity. Okay, means this is the number of earthquakes per year. Okay, there is about 1 million earthquakes with magnitude less than 2.0, which is insignificant. Okay, and the number is lower, okay, for the higher magnitude of earthquake. And then for the Richter scale, the top is 10. Okay, the top scale is 10. So this graph is released in 1999. So it must be about around here, the 2004 earthquake in Aceh. Okay, and if we correlate to the energy release, which is equivalent to the kilogram of explosive, we can see that the increasing, okay, the increasing of energy release, I mean kilogram of explosive. This is the 56 kilogram of explosive materials being released. So it is equivalent to the magnitude 2.0 earthquake. However, for magnitude 3.0, the energy release is equal to 1.8 ton of explosive materials. So the increment is in exponential, okay, exponential function. So one more interesting to highlight here is the 6.1. Okay, 6.1 here is in Rana earthquake. Rana earthquake in 2015, and also earthquake in Sumatra in February 2022, which the tremors have been felt by a majority major area in Peninsular Malaysia, especially in KL. So it is the scale is around 6.1, and if we projected this one, it is nearly equivalent to the Hiroshima atomic bomb. So can you imagine the 2015 Rana earthquake? If you were in Rana at that moment, so the movement, the ground shaking is almost equivalent to the Hiroshima atomic bomb. That's why a lot of buildings undergo damage, okay, during the 2015 Rana earthquake. Okay, and this is the intensity of scale here from 1.0 to more than 10 of the modified Macaulay. This is the correlation between the potential damage or on resistant structures, potential damage on the non-resistant structures, and then the PGA. This is the PGA, the peak ground acceleration of the ground surface, and this is the peak velocity. Okay, the higher ground accelerations means the higher intensity, and it will give a higher possibility of damage. Okay, earthquake also induce another hazards, okay, which is the most popular is tsunami. If the earthquake occur under the ocean, and seizures is under the lake, and also it will induce the landslide, liquefaction, and then the mud flood. Okay, so you can learn more about this one from Google or YouTube video. Okay, that's all for today for this topic. So you can increase your knowledge by reading some material from newspapers about the earthquake hazard to Malaysia. Okay, where we also have our own earthquake source, especially in Sabah. We have Ranau, Kundasang, Tawau, and Lahad Datu. And in Peninsular Malaysia, we have Kuala Pilah, we have Jerantut, we have Bukit Tinggi, and we have Manjung in Perak. Okay, so that's all. Thank you very much for your attention. Thank you very much.